In this video, we're going to talk about how to integrate sine to the fifth power of x dx. So the first thing that we need to do is we need to split sine to the fifth power into two different parts. And that is sine to the fourth times sine. And there's an invisible 1 here, so 4 plus 1 is 5. Now the reason why we need to do this is because we need to use u-substitution. And anytime you have an odd power, you want to keep one of the trig functions on the outside if you're dealing with sine and cosine. Now sine to the fourth is sine squared squared. Now sine squared plus cosine squared is 1, so subtracting both sides by cosine squared, sine squared is 1 minus cosine squared. And so we need to replace sine squared with that. And so we have this expression. Now we can use u-substitution to get the answer. So we're going to make u equal to cosine x in order that du will be equal to negative sine x dx. Solving for dx, it's going to be du divided by negative sine x. Now let's replace cosine with the u variable, and let's replace dx with du divided by negative sine x. So we have the integral of 1 minus u squared squared times sine x times du divided by negative sine x. And so we could cancel sine, and I'm going to move the negative sign to the front. So what I now have is negative integral 1 minus u squared squared. Now what we need to do is FOIL. But first I'm going to write the expanded form of this integral. So we have 1 times 1, which is just 1, and then it's going to be 1 times negative u squared, which is just negative u squared. Negative u squared times 1 is the same, and then negative u squared times negative u squared, that's positive u to the fourth. Now our next step is to add like terms. Negative 1 u squared minus 1 u squared is negative 2 u squared. So first is going to be 1 minus 2u squared plus u to the fourth du. So now we could find the antiderivative of each term in that polynomial. So the antiderivative of 1 is u, the antiderivative of u squared is u to the third over 3, and for u to the fourth it's going to be u to the fifth over 5 plus the constant c. Now let's distribute the negative sign. So it's negative u plus 2/3 u to the third minus u to the fifth over 5 plus c. Now let's replace u with cosine x. And let's write the expression in standard form, starting from the highest exponents. So it's going to be negative 1 over 5, starting with this one, times cosine to the fifth power of x plus 2/3 cosine to the third power of x, and then minus cosine x plus c. So this is the final answer. This is the integral of sine raised to the fifth power.